Water runs into an inverted conical tank, so the point of the cone is down, at the rate of 9 cubic feet per minute. The height of the tank is 10 feet and the radius at the top is 5 feet. How fast is the water level rising when the water is 6 feet deep? Let's go ahead and draw our conical tank. And some of the info that we have at the top, the radius is 5 feet and the height is 10 feet. So if we picked some water level here, that's going to be some R and some H. Those are going to be functions of time. What they give us is a volume rate of change, how fast the water's going in, so that we've got dV dt equals 9 cubic feet per minute. We want to find how fast the water level is rising, so we want dH dt when H equals 6. Now, looking at this, then we need a connection between volume, and we've also got H and we've got R, so we're going to need to be doing something at some point to eliminate one of the variables. But connecting those variables, volume of a cone is 1/3 pi r squared h. So we do have a connection, we just have too many variables. We want to eliminate the r and leave the h in here because we're looking for a rate for h, rate of change of h. So let's see, how can we connect h and r? And often you just look at your picture and see what kind of geometry or trigonometry or something you can use. In this case, I see that these are similar triangles. The sides here are 5 and 10, and these are R and H. And so I can set those up in a ratio to compare them. So R over H would equal corresponding sides 5 over 10. So R is going to be 1/2 H. Now I can take that and I can substitute that in then right here, and I will have an equation that relates V with H. So it's going to be 1/3 pi 1/2 H squared times H. So that's the volume equals, let's see, if I square the 1/2, I get 1/4 times 1/3, so that's 1/12 pi H cubed. Now I'm ready to take the derivative of both sides with respect to t to get how my rates are related. So I have dV dt equals, this is just a constant, power out in front, that'll make that a 1/4 pi h squared multiplied by the derivative of h. So that's a power rule, chain rule. And there is my equation that relates the rates. I do know dV dt, that's 9, and I want to know what dH dt is when h equals 6, so I can put a 6 in right here. In the interest of room here, I think I will go ahead and do the subbing here and then we'll solve here. So we're going to put a 6 in here that will need to be squared, and we're going to put a 9 in here. So on this side I'm going to have a 9, and it'll get multiplied by this 4 when I bring this over, and divided by the pi and by the 6 squared, or 36. This is 36 and 36, so it looks like it's 1 over pi, and it's going to be feet per minute. So this water level is rising when the water level is at 6 feet. It is changing when rising by 1 over pi feet per minute. And you could always put that in a calculator if you needed a decimal approximate.